Imagine you're handed a perfectly ordinary map: roads, towns, rivers. You're asked to travel from A to B. Before you set out, you make a bunch of tiny assumptions. The bridge at the river is intact. The GPS signal is strong. The gas station near the highway is open. You don't announce these assumptions. You simply act as if they're true. Most of the time, that's fine. But if one is false, the bridge is out. Everything changes. Your route fails in a single, concrete way. Software systems are the same. When engineers draw trust boundaries, the invisible borders between components, networks, or privileges, they almost always make assumptions about what lies on the other side. Those assumptions are quiet. They live in code comments, mental models, and design docs. They are also the single most dangerous category of mistake in security, because attackers don't need to break your strongest defenses. They only need to find which assumptions you quietly relied upon and make them false. So what exactly is a boundary assumption? It's any unspoken promise you make about a context on one side of a trust boundary. Only admins hit this endpoint. Data in this database is trustworthy because backups are controlled. Internal network traffic comes from other approved services. Each of these is a contract you assume holds true. When that contract is violated, intentionally or accidentally, the boundary's protective value evaporates. Let's make this concrete with a very small architecture: a front-end web app, a back-end API, and a database. On the front end, you trust the user's browser to hold a session cookie. At the API boundary, you trust that requests include a valid token. Inside the application, you trust that some services use short-lived credentials and others run with minimal privileges. These are not exotic assumptions, they are the day-to-day scaffolding of modern development. But each is a potential blind spot. One of the most common and instructive examples is the internal network is safe fallacy. For decades, many organizations assumed that anything inside their private network was by definition trustworthy. Firewalls separated inside from outside, and the inside was treated as a safe zone. That assumption survived for years because it often worked. Most attackers were outside, and the firewall was a strong deterrent. But assumptions decay. Developers put more services on the network. Contractors connect laptops. Cloud misconfigurations expose internal APIs to the world. An attacker who compromises one peripheral machine, a developer laptop, a CI runner, or a third-party service, can pivot and move laterally inside the network. Suddenly, that old assumption, which shaped access controls and logging strategies, becomes a vulnerability. The boundary didn't change visually. The boxes and arrows on your diagram still look right, but the truth of your assumption did. Assumptions live in many other forms too. You assume input formats, this field is JSON, and build code paths that pass or serialize data accordingly. You assume authentication checks precede access to sensitive functions. You assume a library's API won't silently introduce dangerous behavior. Any of those assumptions can be invalidated by a malformed input, a missing check, a library update, or a developer shortcut. Attackers exploit precisely these unexamined places. They perform reconnaissance to find where assumptions exist and then craft actions that violate them. SQL injection is a classic. Code assumes an input is safe text, concatenates it into a query, and an attacker supplies input that breaks the assumption and executes arbitrary SQL. Server-side request forgery exploits the assumption that a server-side URL is safe to fetch. Supply chain attacks exploit the assumption that third-party dependencies are benign. These are not abstract examples, they are the art of turning assumptions into capabilities. So what should you do about it? The short answer: make assumptions explicit, minimize them where possible, and treat each assumption as testable and observable. First, document the contract. For every boundary, write down the assumptions. Is this endpoint only reachable by authenticated users? Do we assume that messages are signed? Are there network-level protections? When those assumptions are explicit, they can be tested, code reviewed, and automated. A living contract turns a mental model into operational reality. Second, fail closed, not open. Where possible, Design systems so that violations of assumptions cause denial, not silent acceptance. If a token is missing, fail the request. If an environment variable isn't present, refuse to boot. Implicit acceptance lets errors slip through. Explicit rejection forces examination. Third, shift left testing of assumptions. Don't wait until production to discover that a library change broke your contract. Add unit tests, integration tests, and CI gates that confirm expected invariance, schema shapes, authentication flows, and privilege boundaries. Use fuzzing to probe parsers and contract checkers to verify message formats. Fourth, minimize the blast radius of any single assumption. The principle of least privilege limits what an assumption can unlock. If a component only needs to read a single column of a table, give it read-only access only to that column. If a service only needs to call a particular API, restrict its network policy to that endpoint. Smaller privileges mean smaller consequences when assumptions fail. Fifth, observe and monitor. Assumptions are only useful if you can detect their violation. Instrument boundary crossings with structured logs, correlation IDs, and metrics. Alert on anomalies, sudden access from new IPs, tokens used outside normal hours, or service accounts performing unexpected actions. Detection turns a silent failure into an actionable event. A useful mental model here is to think of assumptions as promises that can be audited. Each promise should have three properties: who makes it, what it guarantees, and how we verify it. The backup service will never expose credentials is vague. Rephrase it: the backup service stores credentials in an HSM, signs requests with ephemeral keys, and has automated checks that detect key leakage within 5 minutes. Now that's testable. There are also more subtle, time-related assumptions, ones that involve sequencing. Time of check to time of use problems happen when you check something and then act on it later, assuming nothing changed in between. For example, checking file ownership before opening a file, but leaving a window where an attacker can swap the file, turns a benign assumption into an exploit path. Concurrencing, caching, and async processing create these risks in surprising places. Thinking of time as part of the contract reduces them. Another category is delegated trust. When you accept third-party libraries, cloud services, or contractor machines, you are delegating a piece of your security to someone else. That delegation is itself an assumption. You assume the vendor won't be compromised, that they patch vulnerabilities responsibly, and that their service-level agreements hold. Treat delegation as a formal risk with controls. Require signed SBOMs for dependencies, use supply chain scanning, and isolate third-party runtimes. A practical habit that helps is to run a simple assumption audit. Take a component, draw its boundaries, and write down every non-obvious thing you rely on. The list will include things like: keys are rotated monthly, an internal API is unreachable from the internet, or a developer workstation is never internet-facing. For each item, ask, how could this be false? What would happen if it were? What controls detect or mitigate that scenario? This exercise is low effort and high yield. Finally, accept humility. Some residual risk will always remain. The goal is not zero assumptions, that's impossible, but to make assumptions visible and to reduce the likelihood and impact of their violation. Treat them as first-class citizens in your architecture. Document them, test them, and instrument them. To wrap up, boundary assumptions are the quiet architecture decisions that determine what your system trusts. They're easy to make and easy to forget. Attackers search for them because they are often the path of least resistance. Your defense is straightforward. Make those assumptions explicit, minimize privileges, automate validation, and monitor the places where your mental model meets reality.